everyone! Welcome to Solubility Showdown, Street Science Edition. I am Ryan.
And I'm Chad. Today, we're bringing out science out of the room and bring it into the real world.
Our goal today is to find out how dissolving a solid in a liquid can affect not only how fast it dissolves, but also how it can change the boiling point and freezing point of the liquid.
Yup, we'll find some random people and ask them to help us with an experiment to explore how different factors affect dissolving.
So, ready to see how science works in action? Let's go find our participants. Looks like we found three curious volunteers. Let's test their science skills.
But before we start, what do you think will happen if we try to dissolve salt and sugar in warm, hot, cold water?
I think hot water will dissolve it faster.
Also, if you stir it, it probably dissolves it faster.
Those are great guesses, or what we call hypotheses. So our hypotheses are:
smaller solid particles dissolve faster. Stirring helps solids dissolve faster. Hotter water makes solid dissolve quicker than cold water.
And to keep our experiment fair, we also set our variables.
For independent variables, temperature, stirring, and particle size. While for the dependent variable, time it takes to dissolve. Lastly, for controlled variables, same type of solid, same amount, 1 teaspoon, and same water volume, 200 millimeter.
alright, let's set up the experiment.
For the sugar dissolving test, we will need cold water, hot water, and room temperature water.
Today, we have 3 glasses. One consisting of room temperature water, hot water, and cold water. We'll see which one will dissolve sugar the fastest.
I add 1 teaspoon of sugar into each glass at the same time.
And I'll find how long it takes to fully dissolve.
Wow, the hot water is already turning up fast.
They're carefully observing and recording the time it takes for the solid to disappear. For this part, we will need salt and sugar.
Now, let's test how particle size and stirring affect dissolving speed. We'll use rock salt and fine sugar with and without stirring. How do the stirring part? Slow and steady.
I pour 1 teaspoon of each solid into their glasses.
And I will measure how long each dissolves and note on what happens.
They'll compare which dissolves faster, big rock salt or fine sugar, stirred or not stirred. The results for temperature test are: for cold water, it's 1 minute and 23 seconds, while for hot water, it's 1 minute and 13 seconds. And lastly, for room temperature water, it's 32 seconds. And for the mixing and particle size test, rock salt, not stirred, 46 seconds. And for the stirred one, it has 34 seconds time. Now for the sugar one, the not stirred sugar has 37 seconds in time, while the stirred sugar has 45 seconds in time.
The hot water dissolves really fast. Stirring makes a huge difference. No stirring takes way longer.
And the rock salt took the longest to dissolve since it's made of bigger pieces. The results clearly show temperature, stirring, and particle size all affect how fast the solid dissolves.
Alright, scientists, let's answer our key question.
Effect on particle size. Smaller particles dissolve faster because they have more surface area touching the water. Effect on temperature. Hot water makes molecules move faster, so the solid breaks apart and dissolves quickly. Effect of stirring. Stirring helps move water molecules around so they can reach the solid faster.
All our hypotheses were correct. Stirred, smaller, and warmer dissolves faster.
And that's how solubility works. Our goal isn't just to see how fast things dissolve. We also want to know how dissolving a solid affects boiling and freezing points.
When you dissolve a solid like salt in water, it actually changes those properties. The boiling point goes up, meaning salt water boils at a slightly higher temperature than pure water. The freezing point goes down, meaning it takes longer for salt water to freeze.
That's why salt is spread on icy road. It lowers freezing melting point, so ice melts faster.
And that's why seawater doesn't freeze as quickly as fresh water.
So, dissolving doesn't just make things mix. It changes how the liquid behaves.
Exactly. It's all connected. Dissolving affects solubility, boiling, and freezing point. Science is everywhere.
And that's our solubility showdown. Street science edition.
Thanks to our awesome volunteers, Gabriel, Lee, and Earl, for helping us make science come alive.
That was fun and surprising.
Now I'll remember why hot water dissolves things faster.
And why my